No, it's fine. So what's up?
Having
7-1.
trouble converting fractions, I think, into percentages. That's what it is. If you have like a weird number, I better take notes.
There you go. If I had to make 11/12 into a percentage, and I'll tell you this, round to the nearest hundred. So there's got to be a whole purpose for why I have to say that. Obviously, it's not going to come out nice. So if I ask you something like 3/20ths, why would that be nice?
20.
What can I do with 3/20ths that I can't do with 11/12? So it makes percentages easy.
Simplify.
How do you mean simplify?
You multiply and make it 100.
Because if I can make it out of 100, that's exactly what a percentage means. Can I do the same thing with this? No. So here I can multiply by 5, and that becomes 15 out of 100. But sometimes you'll hear people, I used to say this too, you rearrange the symbols in 100, and that's the percentage symbol, right? You got these two circles and then a 1. So all that percentage means is over 100. It's kind of like that number 100 rearranged into a different symbol. So if you can make it out of 100, awesome. What do I multiply 12 by to get 100? I don't know. That's not as easy as this, but what do you have to do then? You actually have to have an intermediate step. You change this into a decimal, and then you change that decimal into a percentage. And then changing that into a decimal involves division. All right. So now if you divide 12 into 11, if I was evil, I'd make you do that. But what do you get when you do 11 divided by 12? Somebody have a calculator?
91.6. 91.6.
Not quite. I understand what you mean, but no. Two things wrong with that. That's not the decimal, and it needs to go out to the nearest hundredth place.
0.916. I guess 9.
Keep going.
6. And then it's a 7.
So 916.
6 repeated, and then there's like
Okay,
a
so
7.
9167.
Yeah.
Now why did it have to go there? It wants the nearest hundredth percent. And I'm going to have to move this decimal once twice, so that would become the hundredth place after I do that, right? So if I want a decimal, I've got to go out 4 places if I want the percent to go out a couple. Because what would this be as a percent now? What do I do with this decimal to make it into a percent? Yeah, once, twice. Okay. So there will be a few problems where I ask you to do that out by hand, just to continue getting practice with the division. But on several of these, I'll just ask you to convert directly using the calculator. That's fine.
Dang, I feel like I did this whole chapter wrong.
Uh-oh. I mean, if you did the same thing here, if you did 20 into 3,
Well,
you did 3 divided by 20,
right.
huh?
I did those right.
Cool.
Just those lines.
Okay, so when the bottom can't become 100, you've got to do the long division. Yeah. And then it's just a question of where they want you to stop. So you got to look to see where they want you to round to. Cool.
Cool.
And why does this make sense? As a percentage, this would be what percent of 12 is 11? Right, 11 is the part, 12 is the whole. So it should be, 11 is almost the entire 12, right? If I had 12 Twinkies left, and somebody took 11, they took almost all my freaking Twinkies. Why is that a big deal? Because Hostess is out of business. There won't be any more Twinkies made. So all those apocalyptic things in the future where the Twinkies survive, that's not true. We're going to eat them all up in the next few weeks.
The judge stopped that.
So why does that answer make sense then? 11 out of 12 is almost all of them, and my answer was almost 100%. Guys. People. All right. So anything else from homework?
Yeah. Sorry.
Sorry. The whole point.
23.5%. And I like decimal and fraction.
Okay, cool. So we did one sort of like this last time. This is a little evil because it's got a fraction inside of a percent. But the easiest way to take care of this is to first convert this number itself into a decimal part. It's still a percentage, but it's going to have a decimal number in front of it. So 23.5 is better known as 23.5. Cool. Now, how do I convert any percent to a decimal? And I know that sounds weird. Hopefully nobody, I know there's a decimal in that number. This is a percentage number though. To convert it to a true decimal is a true number. It's not hiding any division by 100. Yeah, so I gotta move it once, twice. 0.235. Cool. So I don't know if this helps out. Anything I've ever said, the DP thing. I think the most immediate thing is the decimal number will always be smaller than the percentage number. That's a quick check to make sure you move the decimal the right way. And 0.235 is definitely smaller than 23.5. So on that level, things look good. Now how do I make that into a fraction? Yeah, tenths, hundreds, thousands. So 235 thousandths. Cool. Does anybody work anywhere where you talk about stuff like parts per million? Yeah, parts per million. What do you do?
Medtech?
Oh, so you're talking parts per million in what sense?
And like oxygen, amounts of O2 that you get to the body.
Gotcha. That's awesome. So he's talking about parts of the oxygen as how much oxygen per blood, right? Is that what you were talking about in that sense?
Body, time, yeah, essentially.
Roughly, okay. So parts per million is not really a percentage because percentage is out of 100. But when you convert it to a fraction, if you said like 20 parts per million, that'd be 20 over a million. And then you can convert that back into a percentage. You have to make it over 100 then, right? Or you make it into a decimal, move the decimal place over. So it's kind of cool. There's an immediate kind of, not a percentage, but the same kind of idea, part out of whole. You hear parts per million all the time, especially when they talk about pollution, parts per million if you live in Los Angeles or something. Exactly. Particulates in the air, how many parts per million there? Okay, cool. Any other questions? Jim.
Can you give me some examples of 7.3?
Okay. 7.3, it's really all about doing this kind of equation. 11 is 28% of what? And I told you could do this either way you want to. You could do it equation way, or you could do it the proportion way. So if I made this an equation, what would it look like? 11 equals 28% would have to become 0.28. So the minute you put that into an equation, the math does not understand percentages. That is something that we made up for ourselves. Math is like whatever the hell you guys do, I don't care, but you have to make it into a real number, decimal, for the math. Of multiplied by x, because I don't know what the hell it is. Cool. And the beautiful thing about that is, one thing I desperately want you to come out of this class with, like I said before, is knowing how to solve equations. So it's a very basic equation, but it continues to reinforce the ideas of how to solve equations. There's always a one-stepper here. How do I do this? Yeah, get that 0.28 out of the way. Divide by 0.28. So x is whatever the hell that is. 39?
9.28.
Okay, cool. Is that cool, Gene? So all they're going to do to you really is going to keep changing what it is you don't know. Keep changing where that x goes.
So basically it's sort of the same as of 7.2.
Yeah, and in fact the point of 7.3 really is, what's the other way to do this problem? How else could I do this problem? 7.3b. I could do is over of equals percent over 100. Personally, I don't think there's a real, that a student doesn't gain anything by doing it both ways. You could do it either way that makes sense. The reason I assigned both sections is that you had that section to deal with if you had a way you liked better. So you can read through that section's examples and stuff if you like this way better, if you like that way better. So if I did do this way, what's the is number? Careful.
Oh, sorry, 11.
11 is, so 11 is the is number. The 28 is the percentage, and the of number, of course, I don't know. And then you can just cross multiply.
I think I like the other way better.
I like it, me too. But some of you guys, I think, like this way better, maybe just done this way more often. There's not a damn thing wrong with this, because then you get practice with proportions. You get practice with cross multiplication. Either way, I'm happy. You get practice with something. So here you would cross multiply. And then the last step would be
5.
divide by 28. And look here, we did the same thing here. Divided by 0.28, if I move this over once, twice, I gotta move this over once, twice. That's 1100 over 28. I'm gonna get the same answer.
See, I feel like that way I would forget to move the decimal
Here?
and the percent. I got
Oh,
28.
here. I got you, I understand. That's a problem, you're right. Because here it's built into the equation because that over 100's there. So if you like that way better, do it that way. Anything else in chapter 7? What about chapter 8? We just barely got into chapter 8. Yeah.
Yeah, it was number 3. Would it,
Number 3 where?
sorry, 8.3.
Okay.
I have a question.
Yep.
Oh yeah, 2 and 1/2, so, I don't know if I'm making this more complicated, but would it just, you move it up 2 and then half in between, right? Is that?
Yeah, so to graph fractions on a coordinate system is a little tiny bit strange. So if you had to plot the point 2.5, what is it, 2.5, 3? So just remind me, what's the general idea? 2.5 tells me how far to move, on the x-axis, right? Since it's positive, I'm gonna move up. So this will be 2.5. But then I have to go
Up 3.
up 3. So 2.5 and then up 3.
Okay, yeah, I just wanted to make sure.
Cool. So at that point, you can make yourself little halfway points if you want to.
Alright, thanks.
Now what really sucks is when you get to the point where you gotta plot like 2 and 19/30.
Yeah.
Then you just gotta estimate. If you're doing it by hand, you don't have to be perfect. Yeah. Cool.
Thanks.
Is that right?
Yeah.
Yeah, normal.
Nice.
Oh. So that's kind of getting into what today's gonna be about. We haven't really got there yet. The only thing we did in chapter 8 really was to plot a few points. So this is a really good question because it goes a little bit beyond what we did last time. I didn't really show you how to plot fractions. That's exactly how you do it. It's a little bit weird. I get people when you first start doing this, if I wanted to plot the point 2.5, you put a point there. But that's not where the point is because you haven't moved up 3 yet. So you just have to remember, I move here and then you just gotta go straight up to 3 before you put any point. Okay. So let's get into this question like Norma's got. And actually before we do that, let's do a little quick review. Actually, let me do this. I got a little handout that I wasn't gonna give out till later, but we can do the first one. Do number 1. see what the rest of you guys need to do if this is old news.
I'm the only one with this one.
So what I want you to do real quick, right now, the only thing I want you to do on this paper is number 1. Some of the rest of it we haven't talked about yet. Oh. The other one.
Maybe I wouldn't be in town. The only one in this room. Lucky me.
To represent.
Wait.
I know. Wait. I thought I put an X on it. Maybe I did. I did. That's all right. All right, guys. So do number 1. So 2, 3, 4, 5, and bonus are things we're going to talk about today. So just do number 1.
Oh, not everybody has class this week.
Yeah, I know. Some students self-select an earlier vacation.
I know Mason.
Some teachers allow it.
Oh man, I should.
Some colleges are out this whole week, like Mesa's
Mesa,
out.
yeah.
Grossman has not given in yet.
Not yet, anyway.
I'd rather not have the semester start earlier, go later. So that's what it would have to do. We have this whole week off.
Yeah.
Wait, you said just to do 1?
Just number 1. Do more if you want to.
Yeah.
We will do more later, but just do number 1 for right now. Just looking at part A, just make sure everybody's on the right track. That first number always tells you where to go on the x-axis. And the second number, that's the new axis, so that's going to be the second number tells you go up and down. The first number tells you go left and right. So if I say 0, 2, I don't want to move at all on the x-axis. I just want to end up going straight up, right? Not down, this is not negative. So left and right, I don't want to move left and right at all, but I do want to go up 2. So there's point A. That's one of those that's a little evil. When I put a 0 somewhere, students get a little freaked out about what the hell does that mean. It just means don't go in that direction. What about part B? What's the -3 tell you to do?
Go down.
Careful.
Oh, no, I'm sorry. Go left.
Good, so go left 3.
Oh, no, go down. That's right. Go up, go down,
Oh, wait. But me, I always think up and down like that, so don't freak me out. So back 3, and then up 5. Cool. So back 3, up 5. So there's point B. You can think of it as north, west, east, south if you want. Whatever makes it make sense, right? C. So in C, I want to go
Up to.
back 2,
Yeah.
down 3. Good. So can you, what I was saying earlier is I see students do this. So what's kind of wrong with that? See what I did? So they put a point there, and then they put a point there.
Oh.
And I kind of understand why they do that. There might be a visual to help them know where they are when they start going down, but there's no point there. So don't put a point there. Put a point at the end, the place you end up at the end. So D says,
Floor up. Now floor to the right.
remember the first number is x-axis. It's how much you move on the x-axis. So I want to go 4 right, and then how much do I want to go up or down?
0.
Not. So I want to stay right there. Cool. How we doing? So a lot of mathematics, this is not something that is true that it didn't come at us from a meteorite that fell down. We looked at it, we're like graphing. Wow, this is something we completely created just so we could describe where things are. So it's not, we're not trying to figure something out that is just true by itself. This is a complete human conception. We've totally made this up. It's incredibly useful, right? But it's something that we entirely made up. So if you can understand why it makes sense, why they made it do what it does, it's going to make it a lot easier to remember how the hell to do this stuff. What about part E? Yeah, I want to move, so the first one tells me left to right, so I want to move right 1, and then down 3. Cool. So this is E. Stop doing that. Okay, good. What do you call this point here? What's that point right there in the middle?
0.
0, 0. And it's also called the origin. Yep. Right. What would you call this area right here? Like the whole thing's a plane, but this piece of it is a quadrant because these lines break it up into 4 parts. So
Okay.
quadrant 1, where's quadrant 2? Yeah, here it goes counterclockwise for some reason. Quadrant 2, quadrant 3, quadrant 4. We give it Roman numerals, I guess, just to make it look extra special. Sort of like Super Bowls. Super Bowls. Okay, so that's the real basics of just plotting points. Where these points start becoming interesting, where they make really neat patterns, and where, you know, I'm teaching my Math 176 students, they just learned a brand new way to graph things, and you end up with graphs. Anybody ever play with those spiral graphs? Where you had little gear things that fit into other gear things, and you put your pencil in there, and they make all these cool.
Yeah.
They basically now know the equations that make those kind of shapes, right? So they can make a 3-leaf shape, or they can make an 8-leaf shape, or they can make something called a cardioid that basically looks like a heart. Right? It's not quite that. Right? It is a heart. Yeah. So they call that a cardioid for, you know, from the Latin for heart. Right? So it's kind of neat. We're just getting into this, but there's entirely different ways to represent these same points. So we're going to start doing now something a little more interesting. How do I work with equations? And what would they look like if I plotted their points? So the first step we've got to figure out is how do I get points from an equation? So if we give you an equation like y equals 2x plus 3. So if we have established this method of plotting points, what if those points come from something well defined, like this? All right, now first off, how the hell do I get points from this? Well, to have a point, I got to know what an x is, and then I have to know what the corresponding y is. So the really nice way I can do this is to make what something is called, very creative name, the xy table. It's a table with x and y in it. And most of the time, we consider our x kind of our input variable. is what we're gonna put in, and y is what we're gonna get out. Doesn't have to be that way, it kinda depends on how I wrote this. But isn't, what's the one, y is coming out of something to do with x? Do you guys see that? I'm gonna double x and add 3, and then y is gonna come out. So what could I put in there for x, just to start investigating this thing? What's a good place to start? 0 is an awesome place to start.
Yeah.
So if I plug a 0 in for x, what do I get for y? Beautiful, right? Because twice 0 is 0, plus 3 is 3. So I've got 1 point already. I've got the point 0, 3. Right? So of course, what we're going to do when we kind of get a few more points here, we're going to plot this bad boy and see what it looks like. So now, really, it's totally up to you. I'm probably not going to put in here like 5 million, because I am going to graph it. I don't want my scale to have to go out to freaking 5 million. You could, but let's not. Let's stick with maybe 1. Right? I'm just going to number these just so you can see the work. Y equals twice 1 plus 3. Why am I allowed to do this? And why is my voice doing why am I allowed to do this? What is x? Variable. And why is it called a variable? Because it's allowed to vary from number to number. I can make x whatever the hell I want to. All this sets up is a relationship. If x is something, y is 3 more than twice that. So what's x? I don't know. Let's try 0. Let's try 1. Cool. So what about, we're not done here. 2 times 1 plus 3? 5. So I get 1, 5. What about a negative input? Negative 1.
Where'd you pull it
From wherever the hell I want to. I could put in here square root of 7. I'm not. I could put in here 1.87293. I won't. I could put whatever real number I want to in here. And to be honest, I could even put more than that in there, but all we're going to work with are nice integers for the most part. Is that cool? I might throw, actually now that I just said that, I am going to throw one fraction in there. Why not?
No.
So y equals, if I make x negative 1, y is twice negative 1 plus 3. Does everybody see the connection? I can make x whatever the hell I want to because x is a variable. It can be whatever the hell I want it to be. As long as it doesn't make that freak out. As long as it's not undefined. As long as I'm not like dividing by 0 to plug a 0 in or something. So this is not going to have any problems anywhere. I can double any number I want to. So I can put whatever the hell I want to here. So what happens when I put a negative 1 in there? Twice negative 1?
-2.
Negative 2, so I get y is 1. Let's do one more.
1.
And let's make this one 1/2, just because. Do you have to do this? No, I just want to. For 2 reasons. 1, just to show you I can put whatever the hell I want to here. And 2, to hammer home the thing I had earlier, the question about how to graph fractional points. Would you ever do this to yourself? I would hope not. You don't have to do this. But what do you get when you plug a 1/2 in there?
4.
Yeah, what's double 1/2 is 1, plus 3, 4. Okay, cool. All right. So let's try to plot these points.
Because you're trying to find
Okay. Now hopefully, if you're as messy or messier than I am, you'll get yourself some graph paper to not make me go insane when I'm trying to grade your stuff. Some of us, I like it. Some of us, including me, probably could not exist on a normal sheet of notebook paper and keep our teachers safe when they're trying to grade our stuff. So be honest with yourself. If you need graph paper, get it. You can Google graph paper and print some out just for the cost of paper now. Yep, so look that up if you need to. So what's my first point I could plot? 0, 3. So 0, I don't go on the x-axis anywhere. I just go up 3. 1, 5. So I go right 1, up 5. Negative 1, 1. And then finally, 1/2. 1/2 would be right there. Is that cool? Halfway to 1 is 1/2. And then 4. And look how that falls right in the step. What's going on here? Especially if my scale is better. What are those points doing? Making a line. So it kind of should make sense. The points that come from something that's really well defined should make some kind of pattern when I put a visual to it, right? And this is a very simple pattern because it's a very simple equation. The more complicated you make this, the more interesting patterns you can get, right? Oh, good. All right. So what you can do now is you can connect these points and hopefully make a somewhat straight line. Cool. My scale is better, be even better. So that's the next step. Once you learn how to graph points, you can then start making tables and plotting equations. I want to do one more complicated equation with you. And for your homework, you're not going to do any more complicated than straight lines. But I just want to show you an example of something more interesting. Yeah?
Well, I was going to say, because in this case, since we only found the y, it says y equals, but like number 2 has you finding each one, so then you have to like do the...
Oh, okay, we can do an example like that too.
Yeah.
No problem. So let's do 2 more examples, and then I'll let you try that handout out that some of you guys are probably working on already. Equals what, Jeff? What? You can do it, Jeff. Can you, Jeff? No. Too sorry. Trying to make it not come out too ugly for us. And then not do that. Well,
How you put anything in
all right, so if I wanted to complete this table, so like I said earlier, x is very often considered the input. But when it's written like this, if the equation is written like this, there is no real output. There's no variable by itself that's like waiting for the other thing to do something. I've got twice x minus 3y is 12. And then I got these situations given to me, right? So in the first one, I could rewrite this first problem. Let's number these. 1, 2, 3, 4. What do I know from the first step here? What do I know? Yeah, I know x is 0 in that first one. So in that first one, if I make x 0, now the question really is just solve for y. The biggest mistake I see is somehow on the next step, I see this and people start subtracting 2, and what's the mistake I made?
You're multiplied by 0.
Yeah, that should go away, right? Let the twice 0 is 0. So really all you have is that equation. Twice 0 is gone. So I get negative 3y equals 12. Don't forget the negative. Yeah, good. And then divide by negative 3. You get y is negative 4. Cool.
I get it. Nice one.
So I like it. I get it. It's my favorite phrase, however you say it. And then number 2, the same idea, but now what do I know in number 2? I know y is 0. So I can do twice x, because I don't know what the hell x is. But I do know that y is 0. So then 2x equals 12. X is 6. Cool. Not too bad, right? I mean, this really is actually the stuff that we did almost the first day. It's really just plugging in. If I can give you an expression, I tell you what A, B, and C are, and you can figure out whatever else, you know. We've done that before. So this is really just plugging in values and figuring out what the other stuff is. We've done that before. Number 3.
This is gonna like take up a whole thing of my paper.
Yeah, so on number 3, what do we know? Y is negative 2, so I have 2x minus 3 times negative 2 equals 12. Right, just plug and shove. I know that y is negative 2. So what do I get here?
2x plus 6.
Good?
Negative 6. Divided.
Yeah, divide by 2. So this step should be the easy step, right? Once we plug something in, I should be able to solve for that other letter. So x in this case, when y is negative 2, we figured out that x must be 3 in order for this to be true. So really what's going on is every single one of these points we're getting makes this equation true. So finally, number 4. What do I know in number 4? X is negative 3, so I don't know what the hell y is.
Negative 6. Divided negative.
I did it right.
So now I know y is negative 6 when x is negative 3. Cool.
And then you graph them.
Then you graph them, that's right, and then you connect them up.
She's excited.
I like it.
I didn't like this first one that we did.
I'm going to take this out of here, is that all right?
Probably so.
So lose. Just make some room for my graph. Notice you always have to pay attention about how far you've got to go on your axes so you make your graph big enough. I got to go 6 on the x and negative 6 on the y, so I got to have it big enough to fit. Alright. It's always fun to watch me draw. So 0, negative 4. Can everybody, when we do this work, you can see the points that we've just created, right? And then it's really just plotting those individual points. They just happen to come from a well-defined equation, so they should have some kind of pattern. It's going to be a straight line, but the minute I square one of those variables or cube it or have some other power, or if I square root it, I'm going to start getting curves. They're not going to be straight anymore, they're going to be curved. So for us, they're always going to be straight. If I plot the point 0, negative 4, yeah, don't go anywhere x left and right. I just go down 4. 6, 0.
Oh,
Careful.
no, I'm sorry.
However you mean. Yeah. So definitely go right 6, but don't go up and down at all. So stay on 6. 3, negative 2. So right 3, down 2. Good. See, they're already kind of lining up, thank God. And then negative 3, negative 6. My scale sucks, but it's too bad for me. Okay, and now they should. Oh, Jeff.
If it was a perfect graph,
I
it
got
would
it.
be straight.
Get a giant ruler in here. Okay. Yeah, perfectly straight line. Now, I want to make this point. these are not the only answers. In fact, here's a whole other reason why we grab something. I don't think I've said this yet, and this is actually the most important thing. If somebody asked me, what are all the answers to this equation? How many answers do you think there are? For every single x you can imagine, there's a corresponding y answer, right? So that the point altogether makes an answer. We've only done 4 answers. But the minute I connect it up, every single point that I've gone through, every single point that's actually on my line is an answer to this equation. So this is this is my ultimate, this is what I would have done if this would have been invented yet. I'm such a smart ass. They say, okay, list all the answers. I would have said, made this chart, plotted and said, go find all your own freaking answers. Leave me alone. This is a real quick way to answer that question. What are all the answers to this? There. I don't want those. Well, then go further and find your own damn answer. Leave me alone. It's a very nice, quick way to give somebody all the answers. How we doing? Okay. Now, as promised, I want to do one more. Yeah.
I just had, because in none of the examples, I've run into examples where I end up with negative y equals like 3, right? So then you just divide by 1.
Yeah, divide by negative 1.
Okay.
Yeah, if negative y is 3, y itself must be
Right.
negative 3. So you can actually do the last step. Just think about it. Switch the y, the negative.
Well, I mean, I did that in my head, but I didn't know if you like wanted us to do like the divide by.
No, in that case, you're fine. You just move the negative on the other side. That's perfect. Let's do one more example of a little more interesting one. A little more interesting than you will see, so don't freak out. Okay. Just to show you what could be true, what could happen. So there's our first one that we have a higher power than 1. We have a square on that thing. And the beautiful thing about this is none of the process changes. Math does, the process very rarely changes. But when I have something that's not a straight line, I obviously should do a few more points because I don't know what the hell this thing is going to do. So I always start out with 0. That's not a bad choice. And then I throw some negatives in there, and then I throw some positives in there, just to make sure I see everything that could happen. So at 0, what happens? Yeah, y equals 6 minus twice 0 squared. This is 0, so I get y 6. Cool. So what about 1 and negative 1? Y equals 6 minus twice 1 squared. Yeah, so 1 squared is 1 times 2 is 2. 6 minus 2 is 4. Now watch this interesting thing that happens at negative 1. Y equals 6 minus twice negative 1 squared. What's negative 1 squared? 1. 2 times 1 is 2. 6 minus 2 is 4. I get the same damn thing. Because the equation is squaring the x. So it doesn't care if x is positive or negative. Negative 3 squared is 9. Positive 3 squared is 9. The equation is going to give you the same answer. So my graph is going to show that somehow. Visually, I'm going to see that happening. And then finally, let's do 2 and negative 2, just to make sure what's going on here. Good. So 2 squared is 4, times 2 is 8, 6 minus 8, negative 2. And what's going to happen here? It's going to be negative 2 also, because when I do 6 minus twice negative 2 squared, that's still 4 times 2, 8, so it's still going to be negative 2 at the end. Is everybody kind of with me here? How much do you actually have to notice that before you do? You don't care. You don't have to notice that. You just do each one. And then later you go, oh shit, I didn't notice it. So let's see what this thing looks like. As I warned you before, the minute that you start putting powers in there, there aren't 1. You put a square in there, a cube in there, a 1/2 in there, power, you're going to have some kind of curve. Right? So in this case, let me see. I want a board that has this on it already.
give it transparency and use that.
I know, I'm not that smart. Give me a break, alright. I just hate using that more than I have to be honest. So now I just start plotting points. That's the beautiful thing about this is I can make, as long as I make enough points and I start plotting them, I can start to see the shape of this thing. So 0, 6, 0, 6, 1, 4, 1, 4, and negative 1, 4. 2, negative 2, negative 2, negative 2. So see how this thing is making like a down U shape.
Christmas tree.
Oh, wow.
Okay. Whatever you see.
Connect the bottom two dots, you're messing it up.
Has anybody ever seen that before? You know what that's called? You know what the name of that is? Fred? No, it's called a parabola. This is a parabola.
Can
That's
we
a parabola.
connect the bottom two dots?
Say again?
Can you connect the bottom two dots?
You could, but that would be sort of wrong.
It would be a Christmas
Every point that this goes through must be an answer to the equation. Jordan, so if I did this, these aren't really answers to the equation.
Okay.
At 0, the only place it should be is right there. So it's already kind of defined where it is, so I can't do this, because it's already defined to be in there.
So what if you
Don't
have like
cross
5?
the 0 point anywhere other than.
Yeah, exactly. That's a general rule for this kind of thing, what's called a function. It can't kind of turn on itself. I like it. So I think last time I gave an example about a ball being thrown up. Right, so this would be like the path a ball will take. Maybe. So, I'm sure some of you guys might already be done with this, but if you haven't started yet, do number 2, 3, 4, and 5. And the bonus is there just to keep you a little busy if you get done with it. Call me over if you need some help. So number 2, you don't have to graph that.